So in the last video, we went from carboxylic acid to ester, and we talked about how that works and what we lose and what attacks what and all that other kind of good stuff in there. And it didn't really create anything new. A lot of those mechanistic steps are familiar. We're just kind of rearranging them and putting them in a different order and recognizing that we have a different starting material. So where do we go from here? And the answer is we try to use things that are better. Carboxylic acids aren't that reactive. They don't have very good leaving groups, right? OH is not a very good leaving group unless we add H plus to it. Ethanol is not a very good, or alcohols are not very good nucleophiles unless they're attacking a carbocation. And so the nice thing about carboxylic acids is that they have all these derivatives, and we can kind of replace that OH group with a whole bunch of different other things. And we can make those good leaving groups or we can make them bad leaving groups. And depending on what we choose for our leaving group or for our carboxylic acid derivatives, we can change the overall reactivity of our compound. Okay, so let's talk carboxylic acid derivatives here. Oops. Ooh. There are 4 that you're going to need to know. The first one is an acid chloride. You can also have acid bromides, acid fluorides, right, or acid iodides. But most of the things that you're going to come across are going to be acid chlorides, right? Most of the time, those are the easiest ones to make. And basically, they're like a carboxylic acid, only instead we have a halogen out here, usually a chlorine, because that's an acid chloride. And one of the things that helps here is that one of the things we're going to come back to is that this is a very good leaving group. Okay. And so go back to the video where we talked about carboxylic acid to ester. Remember when we have our leaving group, how we had to make that leaving group and all that kind of stuff. And think about how that might change if we already have a good leaving group installed. All right, the second carboxylic acid derivative that you will need is an anhydride. Anhydrides are not quite as common as acid chlorides. Usually we use acid chlorides, but the anhydrides have this kind of double carbonyl structure. And basically what we're going to have here is this whole side over here is going to be like our chlorine, right? This is also a good leaving group. And so our reaction is going to take place at this carbonyl carbon over here, and eventually we're going to kick this whole group out, right? And so we'll do some examples of that here in a future video. The third carboxylic acid derivative is the ester. The ester is probably one of those, like we said in the carboxylic acid to ester video, these things are stable. These things stick around. They're nice, solid ester compounds. Are generally good, although still reactive enough that things can happen. So esters are when you have a carbonyl next to an oxygen group that has some other carbon group attached to it, right? Could be an ethyl group, methyl group, whatever. And the last carboxylic acid derivative that I want to point out to you is the amide. The amide is when we have a nitrogen connected to our carbonyl. So notice that we're using heteroatoms now, right? We have chlorine, we have oxygen, and then we have nitrogen. And this nitrogen can have however many groups you want attached to it. It can be a primary, secondary, or tertiary amide, depending on how many carbons that nitrogen is attached to. Amides are very, very stable, right? A neutral nitrogen like this is a very bad leaving group. And so as we talk about these carboxylic acid derivatives, we're going to keep kind of categorizing these based on how good their leaving group is. So we're building up to that as we come here. So this is just a straight up terminology video. We've got 4 things that I want you to know: acid chlorides, anhydrides, esters, and amides. We're also including implied in here is that you already know what a carboxylic acid is. So I guess that would be the 5th one. But we've already talked about carboxylic acids a little bit. So I'm going to assume that you are familiar. So the next thing to do is we're going to take these and we're going to actually react them with nucleophiles and see how they differ in their reactivity with nucleophiles.